This video takes a look at one of the more difficult problems that students tend to face in the applications of using derivatives. Up to this point, I've talked about points of inflection for the second derivative test. And I've also talked about critical points for the first derivative test. But now we have this general cubic that we have to worry about. And I'm going to rewrite this because my program doesn't do a very good job with exponents. But in essence, it's asking us this. Let f of x be ax cubed plus bx squared plus cx plus d, and make sure that it satisfies the following conditions. And we want to find our coefficients. So it has to have a relative minimum at 3, comma 3, a relative max at 5, comma 1, and a point of inflection at 4, comma 2. Okay, now one principle that we have to kind of keep in mind is what all of these terms mean. So relative min and max have to do with first derivatives. A point of inflection has to do with a second derivative. And so it turns out that we really don't need the point of inflection. I'll show you what I mean at the end of it. The very first thing I do is create, first of all, taking a look, we have 4 different things that we want to solve for. 1, 2, 3, 4. If we want to solve for these things, we have to create 4 equations. So for solution, we need 4 independent equations. Okay, we need the same number. In this case, x is not our variable necessarily. The variables that I'll be considering are a, b, c, and d. So we need 4. We have 4 variables. We need at least 4 independent equations in order to have a chance at having a solution to this. All right. So let's go ahead and see if we can't manufacture some of these. Well, we know that it crosses 3 points. We know it crosses these 3 points. And so what we can do is we can go ahead and make those 3 of our 4 necessary equations. I'm trying to find a good color here. Let's do white. So equation number 1, we know it passes through the point 3, 3. And so that means that f of x is 3, and so is x. So this is going to be 3 cubed is 27. So it's 27a plus 9b plus 3c plus d powers of 3. Okay. A second one, we know it passes through the point 5, 1. And so we have 1 for the y and 5 for the x's. And so that's going to give us 125a plus, and then we're going to have 25b, and then we're going to have 5c plus d. For our third, we can use our point of inflection. So we have 2 for our y, and then 4s for our x's. And so that gives us 64a, 16b, 4c, and 1d. It gives us 3 of our necessary equations. All right. Now we need a fourth. How can we generate a fourth equation that is independent? Well, let's take a look at the relative minimum or maximum. I'm going to choose the relative minimum because it's the smaller x value. But ultimately, I know that f prime of x, if I check out the first derivative here, we have 3ax squared plus 2bx plus c. I also know at the point 3 comma 3, the derivative, since it's a relative min or max by our theorem that we had learned about prior to this, we have a theorem that says relative mins and maxes can only occur at critical points. This is a polynomial. It doesn't have any points where the derivative doesn't exist. And so that means that our derivative at 3 must be 0. Okay, so let's find our derivative at 3. And that is 27a plus 6b plus c. That also must equal 0. So 0 equals 27a plus 6b plus c. There's number 4. All right, so let's take these 4. We have 0 is equal to 27a plus 6b plus c. And now, to find out if they're independent is kind of a pain in the butt to check, but essentially, when you go to solve this, and this you can put in matrix form, or you can solve using the old methods. I don't recommend it. It's going to be kind of a pain in the butt. I'd use a calculator. But when you go, if you have any, you should have something that looks like this. 1, 0, 0, 0. Now we have 4 equations. So we're going to have 1, 0, 0, 1, 0, 1, and zeros everywhere else. And then we're going to have an augment. These are going to be our answers. This will be A, this will be B, this will be C, this will be D. If you don't have that, and you come up with something like, say down here, you come up with 0 and 0 for the bottom, then that means that they're dependent. It means you have issues, and you don't have 4 independent equations. So you'll have to try something else. I happen to know this works because I worked it out, but you'll have to try something else. A first thought that I had was, let's go and we know that the point of inflection has to have a 0 value for the second derivative, and so I tried the first derivatives and the second derivative as 3 of my 4 equations. The problem with doing that is that the second derivative is actually dependent on the first, and so you come up with a dependent, and this is where you would get something like this, 0 equals 0 kind of thing. And so that would basically tell you that you have a dependent set of equations, and that you can't find a unique solution to the problem. So you need to. I always like to choose points as as the start of my process. After that, then I'll go to the derivatives and that sort of thing. Obviously, what you do after this point is you check it. And so once you get your values for A, B, C, and D, then you want to go back and you want to plug those in and see if you come up with the requirements. And so, for example, here, when I work through that matrix, my answers turn out to be A is equal to 1/2, B is equal to -6, C is 45 over 2, no, 45 over 2, and D is equal to -24. All right, so now what you would want to do then is write out that equation. I wondered why it was acting so fat. I had the pen on instead of the pencil. You want to write out that equation. So you have f of x is equal to 1/2 x cubed plus -6x squared plus 45 halves x plus, and of course you can exchange these for -24 and -6. Now you want to take the derivatives and say, okay, let's take the first derivative, and then we get 3/2 x squared minus 12x plus 45 over 2. And then we take our second derivative, and we get 3x minus 12. So what we want to do is we really do want to check to see, is, now that we have that, 0 equals 3x minus 12, that means that x is equal to 4, which is the x value of the point of inflection. So we satisfied that requirement. You want to be able to check these things. Okay, so once you think you have it done, go back and check and make sure that they all work. And you'll find out the first derivatives work as well. That's how you tend to work these problems.